Hi, everyone, and welcome to the August session of the Stanford AIMI Center Happy Hour series. My name is Akshay Chaudhari, and I'm an assistant professor at Stanford University, and I'm one of the associate directors of the AIMI Center. And I'm super excited to have a great panel of hosts joining us today for our happy hour. And with that, I would just like to get into it. And one of the formats that I wanted to use for this happy hour was, in addition to our panelists introducing themselves, I figured I would poke them with a question to get some initial conversations going. So maybe we could start with a couple of introductions, but I also wanted to ask these panelists what they think about the recent trends that have been coming up in the machine learning space about building big foundational models that could be fine-tuned for arbitrary uses. So why don't we go ahead and start with Rogier on this one. So please introduce yourself and tell us your hot takes on foundational models.
Thank you, Akshay. So I'm Rogier from the Sluijs. I'm a postdoctoral student at the AIMI Center. I'm originally trained as an MD, and I'm currently working as a machine learning researcher. My research topics are on self-supervised learning and COVID AI models. So that's closely related to foundational models too. My opinion, at least, is that they're super exciting, of course. They probably will be the future of medical imaging models, computer vision models for medical tasks. And I only think that the current models that are already out there are not going to be generalizable to the medical field. And we should really work on medical specific models. So that's my take on this.
Awesome. Thanks for getting us started. Maybe we can go ahead with Sharon.
Hi, I'm Sharon. I just graduated from my PhD at Stanford, working on generative models and applying them very much to medicine in several different projects. Getting to work with Akshay, which is one of the best opportunities. And around foundation models, there was quite a bit of buzz on that large paper that came out to mainly define the space. But yeah, a lot of the big foundation models are generative models. And we see them as, just these models that are trained on literally everything that we can get our hands on in terms of data. And then we kind of, now as humans, we're kind of looking at them and realizing that there's this interesting emergent behavior from them that things that we weren't expecting, right? And so I think this could be great for medicine in the sense that, there will be these large models that everyone can maybe build on and create their own have multitask kind of capabilities. But at the same time, we should probably be cautious about emergent behavior, especially in medicine, especially if those emergent behaviors are a little bit weird or not expected, or I guess not desirable is the worst case.
Awesome. Thanks for kicking us off. Maybe next we can go with Alaa. And I think it'd be great to get your perspectives on the recent AIMI Symposium and the Bold Air Summit. And just to get your thoughts on what were some of the takeaways about some legal and ethical considerations of AI models.
Thanks actually for the introduction, and it's a pleasure for me to be joining. I'm Alaa Youssef. I'm a postdoc at Stanford AIMI as well. My research focuses a bit more on the ethical and regulatory part of AI in medicine. Specifically, I focus on how we can implement AI in a safe deployment setting to ensure what Sharon was talking about with respect to the uncertainty and chaos that happen in medicine that AI would not wrong to impact patient safety. I think the AIMI Symposium this year in Bold really had overlapping themes, and overlapping themes with respect to ethical was, was really interesting to see that patients actually are interested in participating as stakeholders in AI regulation, and how these regulatory and governance bodies should develop policies. We have seen that more of a push towards, more than having for patient consent form to consent for data sharing use, but how we can move towards patient consent that for a learning healthcare system and the data is being used for good. And I think one of the key challenges that remains still to be addressed is the legal implications of AI, and when AI is in the best interest of patient, yet it's not part of the standard of care, who becomes liable is becoming a really critical questions that require further answers. So these were really interesting, and I think one of the most interesting theme to me is actually seeing this year at AIMI and Bold, there is a lot of collaboration between academia and industry that's actually moving forward towards really practical solutions, more than just talking about collaboration, but we're seeing how those collaborations are actually yielding more important results than a single institution, whether academic or industry, operating on their own. So these are very promising takeaways from both AIMI and Bold.
Yeah, thanks for that, Alaa. And I think that's a perfect segue to introduce Hugh, who has one foot in the academic world, one foot in industry. And if you don't mind introducing yourself and maybe just thinking about what are some of the trends that you're seeing in terms of new research in academic circles, and what you're seeing is being done in industry, and are there any translational gaps that we should think about closing?
Thanks, Akshay. Hello, everyone. I'm Hugh, radiologist in the UK. Done a couple of startups in the machine learning space in healthcare, and now I consult people on the regulatory health economics and clinical study design for the validation of these kind of products. You ask about what's happening new. Well, in industry, not much is happening new on the technical side. We're still very much relying on the computer vision deep learning models. I've certainly not seen any new types of networks make it into a productizable form, or certainly not being up for sale yet. But on the academic side, like you say earlier in your earlier question, foundation models are starting to gain some traction. I remain slightly skeptical that they're ready for use in the medical domain yet, because they are so broad and generalizable. I see the attraction of the idea behind them. If you think about how humans develop, we are essentially foundation models as babies, and we create a general awareness of our environment, but we have a focused education to specifically train at doing expert tasks. And I think that's going to still maintain for AI models over time. Otherwise, in academia, I'm seeing a lot more success stories on federated learning, which I was also quite skeptical about. But people are starting to make stories that make it sound like it can actually work if you get your labeling paradigms correct across multiple sites. So small steps forward in academia. Industry is kind of still churning out the same stuff, trying to get that first layer of AI into hospitals, which hasn't, we're at the very, very early adoption phase of those early models. So still a very nascent industry at the moment.
And it's interesting that these themes about academic and industry collaborations are coming up, because this was a big focus of the AIMI Symposium too. And I think for this happy hour, we're trying to review questions that we couldn't get to in this AIMI Symposium. But I just want to paint the panelists here based on your experiences. What has worked in terms of generating better academic and industry collaborations, and what hasn't worked as well? And maybe the second part of that question is, from an academic perspective, it's kind of clear what the collaborations look like. But when partnering with industries, one typically thinks about working either with a medical imaging provider or maybe a pathology provider. But now, as we're talking about these foundational models, does it make sense to have a clinical industry collaborator and a compute provider? If we can't get two people in a collaboration working well together, does it make sense to have three? Curious to hear if any of our panelists have any thoughts about that. Maybe I'll start with Hugh, and then we'll snake backwards.
I was good to talk about the most recent news from Google Health, who are sort of disbanding their Google Health part of the business. And I think maybe they've realized that it is harder than they originally perhaps thought. And maybe they are going to step back and as you say, try and take a more generalized approach of partnering with whole healthcare systems rather than individual sites. Who knows where the future will take them. I think going to the first part of your question, what's a good example of this? International viewers and some of the panel won't be aware, but here in the UK, the government has put millions into funding industry academic collaborations. We have a whole grant system designed for startups to apply for money to work with hospitals within the NHS, and that has been very successful so far. I'm aware there's similar things going on across Europe. Germany have got a streamlined track for this kind of thing as well. I'm not so visible on what's happening in America in this regard, so maybe one of the other panelists can talk to that.
Yeah, I'd be curious, Sharon, if you have any thoughts coming from a different perspective, kind of more on the core machine learning and a basic science perspective. Have you seen any examples or heard cases at Stanford that have worked well or worked poorly in the past?
Yeah, well, I can speak to the fact that, especially as we talk about foundation models, it is getting to the point where, compute is a serious resource that is needed to run our models, and it is very costly. There is more and more work to get it working across a lot of different machines. Of course, there are also startups helping with that. And I would say one great thing about an academic partnership is that in academia, you often get a lot of credits for cloud compute. And in that sense, it's great. And a great way to also leverage some compute is maybe working with industry where, there is sufficient financial resources to pay for more cloud compute. And I think that would enable more and more. That being said, I think open sourcing from the industry perspective, realizing that your academic partnership might turn into the biggest bang for their buck in terms of from the academic perspective is to open source a lot of these things, because open sourcing a foundation model would be huge in medicine and help so many different people. So yeah, I'm looking forward to seeing that happen. I wonder who's going to do it first.
I think that's going to be the academia first. I mean, the industry doesn't have any access to medical images at this point, or at least not as much as we have. But our problem is that we don't have enough compute. So we definitely have to work together to make things work. And I think it's getting better than it was before. You mentioned the credit plans. They're great, but still we have to apply for credits every time. And it's basically not enough yet to create a real foundation model. You would need so many servers to get it running and to get a really good model with billions of parameters. So I think it will definitely take a lot of years before we'll get there.
And Alaa, I'd love to hear your take on some of the ethical and legal perspectives of this. I think we're learning a lot about models such as GPT-3 that have just been trained on such a large corpus of natural text, but people are trying to learn that there are specific biases within that that may marginalize between different subgroups. Knowing what we know right now, are there any steps that we should be thinking about before training these large unsupervised or self-supervised models so that we aren't embedding some of these negative or harmful biases that may be prevalent in medical data?
I think, actually, this is a great question. I think this is also more coming with different models and training sets on the fairness and equity of algorithms. But I think one of the more recognizing that we need a team approach to this where everyone is sharing data from diverse sets, because we realize that we're limited by the type of the diversity of the data sets we input to any model. So I think as we think collaboratively, whether through collaborations with academia and industry, is how can we work together to get diverse data sets? How can we be transparent about the data set we have and what are the limitations? Can we share some of the limitations with the public to kind of show them that, these is the limitations of the data set that we're acknowledging, and more of that transparent communication of what is going right and what's going wrong is going actually to increase the public trust in that both academia and industry are truly working towards finding a middle ground that is still grounded in everyone's interest, and it's not encoding the biases that exist within the data sets and ignoring or not paying attention to the already marginalized groups and equity-seeking groups that are known to be disparately impacted by algorithm bias.
And I feel like whenever this notion of algorithmic bias comes in, I think from a technical standpoint, the next question that always comes to mind is, can we try to interpret what these networks are learning? And I think that's a very hot topic too. Can we go away from these black box models, which we keep hearing day in, day out, and think about interpretability? And David posed a nice question in the chat also, asking about what does it mean for a model to be interpretable for a physician? But I think this whole notion of interpretability can be different based on who is using the model. Is it the model developer? Is it the clinician? Is it the patient? And curious to hear some of the panelists' perspective on this. What does interpretability in machine learning mean to you? And how can we make that useful, and how can we act on that? Hugh?
So I'm going to approach it from the regulatory angle. What it means from a regulatory point is known as usability. And you have to do what's known as formative usability testing before you can get clearance in most jurisdictions. And what that involves is actually putting your software with its final UI or user interface in front of the end users and actually running it in a kind of scenario and say, look, does that button make sense? And before you click that button, what do you think should happen when you click it? And making sure people understand the consequences of interacting with the software. And then obviously bug fixing and things along the way. That's one aspect of the interpretability, because the user interface also affects how you might interpret the result of the models behind the user interface. The second bit is, I think what you're getting to is, how do we actually understand how the algorithm made that decision that it did? And for me, that's the less important question. I think if we can prove that it's robust, it is deterministic in that it always will provide the same output given the same input, and that it's accurate, to a certain degree, at least non-inferior to human practice, that should be enough, I would argue, for the interpretability of the algorithm. But I think having that trustworthiness and the good usability combines into a whole sort of interpretable system. At least that would satisfy the regulators.
I agree with you. And adding on this, I think also what Nagim Shah once published a report at Hay, talking about different types of interpretability. So whether it is operational, whether it's engineering, whether it is for clinicians, I think we need to recognize that interpretability means different things for the different groups. And some ongoing research at the lab is suggesting that actually radiologists can trust AI if it is not interpretable, but yet, as you mentioned, it's safe and reliable. But in specific contexts, for example, if you need to use the AI algorithms to inform specific, for example, precise procedure related to genomics or the field of genomics and radiation, maybe you need to know what are the biomarkers the model is selecting upon. So I think it's always the case is going to be, it depends, but it's not going to be that we cannot operate an AI or model if we don't know how it works, given it's proven to be safe and reliable and effective and non-inferior to existing models.
I think it's interesting, and maybe a slightly different take than what you mentioned, saying that as long as models are somewhat accurate and we can quantify the accuracy and we can quantify the robustness, it's a different spectrum of interpretability that we're working on. And maybe we're here in Sharon, as people who build these machine learning models on a day in, day out basis, how do you approach these problems? How do you think about improving accuracy and robustness of models versus also trying to make them interpretable? in an ideal world, we want both, but it's tricky. So curious to hear your takes on how you go about trying to achieve it, and is there something different that you would do? Maybe Rogier can start us off. Yeah.
Yeah. When I hear interpretability, I always directly think of webcams and masks and those kind of things. I think that's it's really important if we could trust them. And at this point, I don't feel like we can trust a GradCam to directly depict what the model has predicted, for example. So I think it's if you use things like that in practice, I think, for example, if you have a classification model, it's really important that the probability that is generated by the model is actually calibrated. And that's something that's often overlooked. So that's something I always try to fix in models. I always try to implement that because clinicians, it depends on how the model is used. If it's used on its own and it's making its own decisions without a human in the loop, it's different than with a human in the loop. Because if there's a human in the loop, the human probably, or the radiologist in this case, would need the probability to come up with its own diagnosis based on that probability, for example. So I always try to focus on that to give them something they could actually use and they could trust. But it's very hard. Yeah, it's still not super interpretable because it always remains difficult how to interpret it, how the model generated that result. But then again, people always like logistic regression and all those kind of models because they're interpretable. But on the other hand, how many people actually know how the model actually came up with that result? So if you add splines or something different to the logistic regression models, they become less and less interpretable as well.
Logistic regression is AI when you're pitching to VCs, right?
Exactly.
Sharon, what are your thoughts as a tool developer?
My initial reaction to what Hugh said about regulators talking more about, I guess, the user experience was yes, neural networks are still relevant to this conversation. And I often think of the interpretability with explainability, and I think people define it a little bit differently. But the way I think of it is interpretability is how much, as even tool developers, we understand our model as we're building it and diagnosing it, I guess. And explainability is what parts of the model can we give to the end user such that maybe this is more attached to the user experience part that would be useful for them in making a downstream decision. And I definitely think that, interpretability is very important stuff around, we can do post hoc analysis. So after we train a neural network, can we do other things to understand what's going on there, poke around on its decisions, or just do purely non-neural based methods that are interpretable, or the building blocks of which are interpretable. Or we could focus on explainability and think about, given where we are now, maybe we have a somewhat robust model under these 10 circumstances. Can we give something that's explainable that, can be leveraged by a doctor or a nurse or whoever that downstream user, or even consumer in some cases, whoever that downstream user is, to make a really informed decision and to use the model safely. And I'm really excited about that. That being said, I feel like I don't see much work in that in research. And I would love to see that. I would love to see more there. I think startups have started to, work in that space a bit more because it's obviously more practical, it sounds like, for regulators. But I would just love to see much more creativity in that arena.
And I think it's an interesting insight because I think it slowly leads towards this notion of, I've built a model, maybe I've gotten FDA approval for it, and now I'm thinking about deploying it. And how does one actually monitor an algorithm in the wild? Are there specific metrics that we should be tracking? How long do we track these metrics for? Can we try to define if there's distribution shifts? I feel like these are all unknowns. I see a few panelists nodding their head, so would love your opinions on that. Maybe Alaa, I saw you nodding your head first, so I'll pick on you for now.
Okay. I think this is an exciting part because I think pointing to what Sharon was building on, there's both technical monitoring and there's also clinician monitoring, which is the understanding how what you're talking about in terms of model and distribution shifts are happening to the models when they're implemented and deployed in practice, but also there's the questions of actually how clinicians are going to engage with the AI models. When are they aware it is impact? When are they aware there's an AI operating in the background or informing their clinical decision making? To what extent, as we talk about explainability or interpretability, which I agree that we Sharon is talking, the more term we can apply to AI is explainability, because the clinician is looking for features from the AI model that they can really clinically reason how it relates to the symptoms or the diagnosis they're saying to arrive at the clinical decision making. But I think we also have still yet to define exactly what those features are. What are the clinician looking at the model, features inputted from the model to really pick on and make that clinical judgment. So I think we need a lot of more research on the human computing interaction phase, where we see how actually clinicians are interacting with these tools. What are they paying attention to and what they're not paying attention to? And how can we work with actually industry? How can industry and vendors work with clinicians to ensure that the models that are being packaged and ready for deployment are really well serving the clinicians and not adding to their to their cognitive load to kind of figure and understand what's going on, and that they are really useful for deployment. Because at the end of the day, if they're not useful, they're not going to be very well used. So we need to collect utility measures on how clinicians are using, and we also need to monitor metrics of performance and shift at the technical side to know when the algorithms are operating safely and when there is a need for kind of an some type of learning from the real data of what's happening. Sorry, that excites me.
Yeah. Sharon, go for it. You're saying something.
And I will say, every time I've given an AI system to a physician, there has been over-reliance on the predictions coming out of the model. And that, then I started to poke around and said, what do you mean there's more cancer now? And that definitely is concerning, and that's related to, safely building out that user experience, such that doesn't happen, or if it happens, it actually is the case that was a valid kind of direction.
I wanted to get Hugh's thoughts on this from more of a regulatory perspective too. Are there specific requirements about what is okay to monitor, what should be monitored, and how does one actually go about that?
So there are requirements. So especially under the European regulations, which have just changed in May this year, there's a whole section on what's known as post-market clinical follow-up, which forms part of an entire package of post-market surveillance. So once something is deployed, and this is any medical device, whether it's AI or a rubber glove, it doesn't matter. You have proactive and reactive post-market surveillance. So proactive is things you do before you put it on the market. So you set up an email address, a phone number to call. You have a user manual, training sessions. You have all sorts of things that you put in place to try and make sure the device works as it's intended to use. And then you have mitigations, or at least a route for people to report adverse events or ask questions or report bugs. That's kind of the proactive side. The reactive side is more important for AI models. So this is about measuring what's happening in the real world as it's making live clinical decisions. Now, the regulations cannot be prescriptive to every single type of model, because that would be impossible. But they're generally prescriptive in the way that they say you should come up with best standard of care or best state-of-the-art methodology for recording a statistically powered subset of the things that you are intending to do. And if you are a very high-risk device, you have to get an independent expert panel to come up with what that would look like, and the regulators will read through that. And I think that seems like a sensible route forward to me. I also am aware that people are now starting to think that we're going to have AI systems that are going to learn whilst in the clinical environment. We all know that's not true. Nothing does that yet, but it could happen. So the regulators are already starting to plan ahead and what that might look like as well. And I think the FDA are probably ahead of the game there on the global regulatory scene. So if I was going to answer your question from a pure regulatory point of view, it would all be about post-market clinical follow-up. What should you be auditing? What should you be measuring? And you have to set yourself benchmarks for what you want to achieve post-market.
And then maybe following up on that, I feel like my perspective about the regulatory market has all been conditioned by the COVID vaccine for the last 6 months or so. And my limited knowledge is there's a need to report adverse events that might come up after some getting FDA approval and actually giving this to patients. How do we think about adverse events for medical AI devices or tools?
I'm just going to jump in and say absolutely necessary. Algorithms are the new drugs. If an algorithm makes a decision that a human either blindly agrees with or was not involved with, and it harms a patient, that is an adverse event. And in regulatory speak, you have two types of adverse events. You have ARs, which are adverse events, and you have SARs, serious adverse events, which in some hospitals they call never events, cutting the wrong leg off or something like that, right? Or things like that. It sounds funny, but it's serious to patients. And absolutely, we should be reporting those, and we should have robust systems. And that's part of your proactive post-market surveillance. You have those robust systems in place, and the users should be aware of and know how to access those systems to report those events.
And I've heard in this conversation this term robust come up at least 5 or 6 times. How do we define robustness? What is robustness? Is it that your system should work for different demographics of patients? Should it work across different hardware that was used to acquire it? Should it not be sensitive to distribution shifts? Is there any way we can quantify some of these robustness issues? Or is it just a term that we'll keep using where the definition keeps changing? Because I've heard robust used a lot, brought across the field, but if I still had to define it, I wouldn't know what's a good definition. Do any of the panelists, how do they think about robustness for medical AI devices and systems? I'll start with Rogier.
Yeah. I think it's important that you define it in terms of where it's going to be used. So if the model is only going to be used for a specific population, that's not changing, or at least not changing anytime soon, then it shouldn't definitely be robust against data distribution shift or something, but it should be robust against all other kind of things that can happen. So there could be another vendor coming in, taking X-rays, and the model could potentially not work anymore. So it should be, I think it depends on the situation where the model is used on what robust actually means. But it's a very hard question to answer because there's no real definition of robust, I think.
I think it's a growing definition. And honestly, I think a huge way, researchers have been poking at this area of robustness is just seeing where the model is very brittle vis-a-vis a human. So I think we very much define robustness in terms of how we just observe the model being, very different from a human, and just like getting, sidetracked essentially by something that is imperceptible to us, but is otherwise it creates such a drastic change in the model. And I think robustness is very much defined as, at least how I see it in literature, defined as, not being able to handle something that otherwise humans can handle. That said, I do imagine in the future, robustness will also extend to things that are probably superhuman, where even an expert person can't handle it. But I think right now it's just, where is it really brittle, where it wouldn't be brittle to us people, or we wouldn't expect it to be really brittle. And that could be just, we changed the camera, or, it's like, it's made from Philips, the scanner now, and not GE. And all of a sudden, all the model predictions make no sense. And so that type of thing is, I think, how we've been thinking about robustness.
Alaa, any thoughts on that?
Yeah, from a machine learning lens, the way I interpret robustness is how the model or anything that being deployed is able to operate or have performance within expected range of performance in a stressful environment, when there's shift in the data sets, or when there's shift in when there's artifacts and images, like there should be kind of a metric, which I have not seen yet, to measure robustness, but it should relate to the stressful and contextual factor that might affect the performance of the AI model. And so far, I think I have been seeing, of course, the term a lot, but I haven't seen really papers that have been trying to delve or explore what are ways we could measure robustness at different environment settings. So this would really be an important way to explore, because we should have similar standards to how we are interpreting concepts and how we are operationalizing them in practice.
And I was reading through some of the questions that were asked during the AIMI Symposium, and there are quite a few questions that revolve around this notion of creating synthetic data. I feel like this is something that this concept has been around for quite a while, but I think with more recent methods, I feel like this is becoming more tractable. Do we think that there could be room for using synthetic data sets, maybe created using generative models, to try to minimize some of these challenges that we see with robustness? And I'll start with Sharon to see if she has any thoughts on this. Obviously,
literally,
who else would I
zero thoughts. Zero thoughts. I don't think about this every minute of my life. Yes, I definitely think we can leverage these models to help us, but they may not be, sufficient. I think is what we found for every task. I think they work for some tasks, but not others. And honestly, I would love to see work on characterizing why they work on some tasks better than others, because I think we've seen that where they disproportionately do help some tasks and don't help others. And I don't think we very much have classified that just yet. And related to this, just like these, almost latent factors, or these little unexpected things from models that we just don't expect. I want to plug a paper by some of our typical panelists, Judy, Matt, and Luke are on, which is Reading Race. AI recognizes patients' racial identity in medical images, which recently came out a couple of months ago. And basically what we found was, while a physician can't tell race in an X-ray, the model can, and the model can easily learn it. And especially if you train the model just for identifying race, it just gets like 99% AURC or something ridiculous. And then, but if you don't train it just for race and you're like training it for some other task of yours, it can implicitly learn some of that. And of course, not 99% anymore. That would be maybe more like 80 or 90, but still, that's pretty good. I mean, compared to, some of my tasks around like, let's detect cancer. I'm like, you can't even get it up there. So it's definitely concerning and something just to keep in mind, and also a reason to continue, as Alaa has mentioned, just continue poking at our models to make sure that we know what they're doing. Yeah.
I see Hugh raising his hand. Yeah.
The fascinating thing about that paper wasn't the fact that it can classify race. I mean, that is incredible. But the more fascinating thing was that it could do so even if you perturbed, distorted, and just changed the image to the point where it didn't even look like a scan. Like some of them were just grey boxes, and you go, yeah, I know what race this is. I mean, that is even more incredible, because the human would literally have no chance whatsoever. If I showed you a grey box and said, this is an X-ray of someone, what race are they? You have no clue. So it kind of starts to just peel back a layer to show that actually we don't understand these models nearly as enough as we thought we did. And Sharon's right, they're picking up on things that are superhuman, that we would never have a chance of picking up on, which is scary if you think about it for too long.
It sounds like almost a practical joke of like, hi, I'm a model and I can't be robust to anything except race. The only thing that you don't want me to be robust to.
There's probably a few chatbot stories there, but this is a really interesting topic of conversation. So if we know that some of these models can pick up on latent features that humans cannot perceive, where do we go from here? Do we change our data? Do we change our model? Do we change both? What's in the future?
I think we should mainly focus on the data here.
Oh, sorry, you go ahead.
Oh, sorry about that. I think we should mainly focus on the data here. And I think the synthetic data sets you just mentioned are a way to mitigate that. They have been used, for example, by Tesla for things that never occur, like people running a highway or something. And we could do something similar for medical images, but it's really hard and it takes a lot of time to do so. But I think by using synthetic data sets, doing a lot of data augmentations, we can definitely make it better than it is currently right now.
Yeah, I was going to say, whoever comes up with the answer to your question, Akshay, it's got the next billion-dollar company. I mean, if we knew the answer, but I agree with Rogier to a point in that it's the cliched answer in machine learning: more data. Well, actually, it's not more data; it's better labeled data. Is more accurate.
How would having better labeled data help in this scenario if our model is picking up on latent features?
Better labeling of all of the substratifications and everything, and having more metadata within it, we may be able to pick apart and tease apart what other data it's picking up on. I'm only guessing at the answer here.
Yeah.
I said, whoever can figure this out is going to be a rich person.
I'll put you on the record for this.
I think this is also closely related to the explainability question, because if the models are looking at different things than the radiologist or other clinicians are actually looking at, it will also be very hard to give them an explainable way, give them an explanation of how the model works. So that's some of the pain points there too. And that's where I agree with you that if a model just works, has a high accuracy and is robust, might be good enough. Sometimes it's just impossible to explain what it's actually doing.
I think there's also an interesting, based just from that comment and related to race, actually, and maybe this somewhat explains or motivates why the model has picked up on it. I've also read articles on how if we remove race as a factor, so you can do things to try to remove it as a predictive factor in a model, it actually disproportionately negatively affects the minority group. And I'm like, oh my gosh. So then we do need to include race in some of our models, and that makes it so challenging because, in some ways, collecting that data is obviously very questionable in a lot of different circumstances. So I it just this super annoying situation that we're in where that is sometimes the case where, if we remove race here, then the model does worse, and it actually does disproportionately worse on the exact groups that we're trying to help by removing race as a predictive factor.
Alaa, any thoughts on this from an ethical or legal perspective? How should maybe machine learning developers think about this?
I think I myself was fascinated with this for a couple of 2 weeks trying to think about it, but then I have to leave it on the side because I really could, exactly what Sharon was looking at is there is studies already when you use it, race. If you do not use race, you get even worse outcomes in terms of the outcomes. And again, if you use race, it's picking so good. I have just not been able to stop my thinking of what is the implications for minority groups or equity-seeking groups who are consistently being marginalized in healthcare, knowing that they're a disadvantage? How will that impact their trust in the healthcare system and seeking access to care in these care settings? What is really critical questions that we need to reflect on and make sure we get this right, because the stakes really here are high. These are people who are already having the worst outcomes, and we don't want to exacerbate that. And at the same level, you need to kind of think at really what transparency you need to discuss with public in here. But I think the one way we can approach this is really whenever something that mysterious, it's always you need to look at it from multiple lenses, use synthetic data, do another runs of data with distributed populations. I think the thinking of the public data sets and using diverse data sets is a key here for us to kind of start teasing some of these questions out and try to get findings before we talk more about this, because it's I want him to tell us maybe what's the answer he's probably guessing on, but I don't know. It's just like I feel like there's really lots of curiosity, and this finding, if communicated to public, it really needs to be communicated in a very careful and thoughtful way to make sure people feel that we are really considering those aspects really, really carefully before deploying anything that could disadvantage them.
And I think this is an interesting issue, and actually goes back to quite a few questions that came up during the AIMI Symposium itself. And I see our YouTube chat also using some of these terms. But this notion of public trust, I think it's definitely in the news nowadays, revolving around the COVID vaccine and really trying to disseminate science broadly. As machine learning developers, what is kind of our responsibility where we can try to ensure more public trust of these algorithms? Maybe there's some bad examples, such as using, facial tracking that have been used incorrectly in the past. Can we learn from this? And at least within the context of medical AI, how do we build systems that can garner public trust? It's a big question, but I would be curious to hear people's thoughts. I'll pick on the people who are nodding their head the most vigorously. So unfortunately, that's you, Hugh.
I'm just enjoying the conversation, and I was actually just laughing at some of the comments. So actually, you want to know how we can engender more trust broadly? Is that the gist of your question?
Exactly. Yeah.
I think trust is something that is earned over time, and I don't think you can define what makes something trustworthy. And in fact, there was a really good example I saw on Twitter posted by Rain Geis. I don't know if you all know him, but he says, different people trust different people. So some people trust the anti-vax doctors who are saying don't get vaccinated, and to them those are trustworthy people, whereas obviously to others they're not trustworthy, and vice versa. So how do you engender general trust? It's really about maintaining that truth, that credibility, that robustness over time, and in the long term, something that's correct will prevail. I don't think there's a shortcut to trust, which I know that every single startup would love to be able to achieve in a technical fashion. But it's evidence, clinical evidence, robustness, showing that you haven't got biases, or at least mitigating them, planning for your post-market, and trying to keep everything from being as safe and ethically sound as possible, as Alaa suggests as well. I wish I could give a more pointed answer, but I think really that's the truth.
Yeah, I doubt there's one right answer for something like this. And it'd be interesting to hear the takes of either Sharon, Rogier, or Alaa about this perspective from an academic side. When you're building algorithms, how do you think about building trust, or do you think about that at all? If I'm just trying out a new neural network, how can I actually think about, well, what will be the long-term consequences if this were successful? So if any of you three want to comment on that.
I think I would start by maybe sharing, giving a shout out to the paper by Dr. David Magnus and the team at Stanford, who thought about the framework of using the ethical review statement when designing studies, because in academia, when we design studies, we technically think of the research protocol to approve that, but then the ethical review statement is a process that actually asks every academic researcher to really think of the impact of the study, if it went right or wrong on the society. And this really brings a lot of insight and reflections to what are measures you can control for within your study design from before inception and beginning of the study, whether it relates to data, whether it's related to how you will test different machine learning models to ensure that you're really paying attention to ethical issues that might arise if things went wrong. And I felt that, it really gave me an insight to think deeper and really think of ways I needed to modify my study design. So I think more of the future needs to be about that. If we think about building studies that will consider the ethical implementation of or the ethical issues related to AI, And also, I echo Hugh that it will be very important to know that connection with the public is built upon relationship, and its relationship with the clinicians, and its relationship with the healthcare system. So there's a need for us to, to make sure that the public would not really know exactly how the system of the infrastructure is built on, but it will count on its experiences and we need to make sure we're getting experiences that are trustworthy for the different subgroups, and building connections and not losing with the implementation of AI the human connection to patients, because this is what really is going to bring people and make sure that, yes, we can see AI is being used for good. And with the concepts of facial recognition and all what could go wrong, I honestly always keep thinking of Serena's young work on ambient intelligence and how that can have a positive impact. So it depends how we interpret it, but we always have to focus on how we build connections and experiences that really build the trust.
I think there's also a role for medical journals here. A few years ago, medical journals would just accept any deep learning model with any data set it was built on. And there were very different reviewing guidelines compared to traditional prediction models, for example. And it's getting better. I think journals are not just blindly accepting deep learning models nowadays anymore. But I think there's a real big role for them, because they kind of decide where the bar lies for what is really science and what is not. And the bar was a bit too low over the last few years, I think.
Sharon, any thoughts?
Yeah, I agree that the journals can definitely help, or conferences can definitely help. I know NeurIPS instituted kind of a broader impact section to just reflect on things, and it drew a lot of criticism, but I think it actually has helped people think about it just a little bit more. It's like, oh, you want to think about, maybe beyond first order effects in the research community, just second order. Let's just start with second order, and then of course move on to third order, fourth order, all of these things. So I think it's starting to be clear that a lot of our models have these consequences. I think the most mainstream ones are, of course, the Facebook algorithm causing, political tension, and having that serious downstream effect.
Yeah, I feel like, especially in regards to some of the criticisms about the NeurIPS change, I feel like any change can be criticized independent of what it is, because it moves away from the status quo. So maybe it's good that we're heading in that direction. But for the last 5 minutes or so, I wanted to pick one of my favorite questions that came up through the AIMI Symposium, just because it gives us an opportunity to think further out and maybe think in a bit more abstract terms. But the question was, if you had to build a new hospital from scratch, how do you think about incorporating AI right from the beginning, from an infrastructure standpoint, from a staffing standpoint, or maybe even an educational standpoint? What would that process look like to our panelists?
Awesome, clean data collection. Use Epic. Oh, sorry, that was controversial.
that might be hard for some institutions. So I guess maybe to elaborate a little bit more on that, Sharon, I guess would one of your requirements be trying to capture all data in a seamless manner so that independent of what the user is 10, 15 years from now, we have some ability to use it? And maybe how would one balance that with just large compute if I'm storing every image ever acquired at Stanford Hospital? Is that the way forward?
So storage costs are actually quite cheap, but compute is much more expensive. So yeah, I think storing as much as possible while keeping in mind patient privacy it would be very, very valuable.
I was going to say, if I was going to build a hospital from scratch, forget about AI for a decade and just work on just digitizing it. Because honestly, I've worked as a doctor. Get rid of all the paper, the fax machines, the pages, everything, and create a purely digital environment. And don't just buy software from lots of different independent third parties that doesn't really integrate. make everything web-based, have everything API-driven. The reason why the internet has exploded is because it is on an open source, web-based, all sorts of common programming languages that people can plug into. Hospitals are just closed architectural systems that are a nightmare to add things in. And what you end up is with IT systems which are just being underpinned by one tiny framework, which if that falls, then the whole thing crumbles. So I would forget about AI if I was going to build a hospital from scratch and just work on digitizing the whole thing first.
Are there specific areas within the hospital that you see more of these digitization challenges in specific departments or maybe with specific IT backends?
Yeah, psychiatry. I've got no idea how you digitize that.
Yeah.
But then, some professions, radiology, pathology, because it's very image-led, is now purely digital. But yeah, the ones that are very physically demanding in terms of like intensive care or obviously surgery, where you have to physically be operating, it's very hard to digitize aspects of it. But we should digitize what we can, where we can. Push for full digitization. We should be Jeff Bezos about it. Digitize everything. Once you've got that data, then you can build tools that can help make everything efficient.
Will
And
people
then
wear
send that
Google
data
Glass?
to space.
Oh, no. Will people wear Google Glass, Hugh?
Do people wear Google Glass?
No, like would the surgeons wear it? Like would that capture enough info?
Yeah, I'm sure they'd love to wear Google Glass goggles if they could afford it. Yeah, of course.
Yeah, at least from a research standpoint, I've come across quite a few research applications where tools like the Microsoft HoloLens are actually being used during surgery, where there might be some pre-surgical planning medical imaging that's required, and then that's overlaid in real time during the surgery to help guide the surgeons to resect the right parts of the body or just have a better anatomical understanding. So I definitely see some really interesting application of either virtual reality or augmented reality within the surgical space. But I haven't seen any clinical deployment of such a system. Most of it has been research studies, but I'm really excited by the space.
I think to me, healthcare needs to focus on purpose of data collection, and the purpose should be grounded in building a learning system, which means investing in the people who are working in the system in terms of education and training, and create the data management plans, because we know that there is a lot of missing data, which already with the misrepresentation and the minimized under groups, that makes it even harder for us to build good data that we can train models on. So it's really important for health system to really invest in this, because this is the base of the pyramid to build on. If we don't have that good base, we can't go up. I think we need to digitize lots of things that relates to population health, so we're able really to build models that can think of preventative healthcare rather than reactive healthcare. So we really need to think of how we carefully lay that infrastructure, and that the tertiary systems are not disconnected from primary cares. We need to really think that infrastructure is not only within the hospital system, but it expands within a healthcare that is virtual, that is digitized, and that attend to the underrepresentation in healthcare in general of the different groups from the get-go.
And I think both your response and what Hugh mentioned, and something that I'm seeing in the chat, also mentions this notion of interoperability of data too. And I feel like being able to connect data from my specialist versus my primary care physician, having both of them be able to view my medical record, I feel like that would be a step in the right direction and could be non-trivial a lot of times. But sorry, I didn't mean to cut you off right here.
Oh, no. But just starting about like how I would design a hospital, I think I would definitely focus on digitizing it, but I would also focus on reducing the administrative burden. So that's like the main point here. So clinicians actually have time to talk with their patients again. And the other thing is, and you briefly mentioned it, is on education. So what can we expect from AI and what not? Maybe the latter question is the more important one. Like, what is AI going to bring us, and what do we still need to do ourselves in the future? So those are the two things I would build my new hospital on if I were in charge.
Yeah, it seems like half the responses revolved around the role of digitization. and not necessarily on using the next best and greatest algorithm. So maybe a note for any entrepreneurs in the audience, if you want your next unicorn, it doesn't necessarily have to be that shiny deep learning algorithm to solve the real problems. And I think that would clear the most roadblocks. But in any case, we're almost at the top of the hour. So I wanted to thank all our panelists for joining us today. I think this was a great conversation, and it was nice to be able to get to some of the questions that didn't come up during the AIMI Symposium, and also to take questions from the audience. But it was a pleasure chatting with everyone, and thank you everyone for your time. And thanks for all the people on YouTube tuning in live also. Hope everyone has a wonderful weekend. Bye, everyone.